The average rate of change. The average value of a function. Are they the same thing, or are they completely different? For those of you who don't know the answer, don't worry. We'll explore the differences between the two today. Let's start out with the average rate of change.
The average rate of change, or average slope, tells you the slope of the secant line, or with regards to a position time graph, it would be the average velocity between 2 points. To find the average rate of change, you use the equation average slope equals f of b minus f of a over b minus a. Now we're going to do a practice problem. In this problem, s of t equals 2t cubed, and that equation represents the position of a race car along a track measured in feet from the starting line at time t seconds. Find the average velocity from time 2 to time 3. To do this, we just need to use the equation I showed you earlier, which is f of b minus f of a over b minus a. And in this example, a equals 2 and b equals 3. Now all we have to do is plug all the numbers into the equation. So, f of b will equal 2 times 3 cubed minus 2 times 2 cubed over 3 minus 2. And that equals 54 minus 16 over 1, which simplified equals 38. And so the answer is 38 feet per second. Now I'm going to go over some common mistakes. For one, when you're doing these problems, make sure you make the equation f of b minus f of a over b minus a, and not b minus a over f of b minus f of a. Another common mistake is to make sure you have b and a equal to the right numbers. It's common to switch these two up. For example, if you were to say a equals 3 and b equals 2. Lastly, make sure you don't confuse the average rate of change equation with the average value function, which Rishi is about to tell you about.
In contrast to the average rate of change formula, the average value of a function formula finds the mean value of the function on a particular interval, rather than the slope of the function. The formula involves taking the integral of a function, f of x, from a to b, and dividing the result by the length of the interval, or in other words, b minus a. Now, there we have it. That's the formula. But on many AP tests, you may not see it written like that. You may see it more written like this: 1 over b minus a times the integral from a to b for f of x. Now, there really is no difference between both of these formulas. The only difference is the numerator here, which is the integral of f of x from a to b, just got moved to the side, so that 1 over b minus a would be by itself. But that's how many AP tests have it. But you should know it's just the same thing as that. Both will give you the same exact result. Now, we're going to look at some sample AP problems next, and I'm going to show you how to solve them. Alright, so here's a great example of an AP style problem that deals with the average value of the function. Here it's asking this. The average value of the function f of x equals cosine half x on the closed interval from -4 to 0 is. And then there's 5 different options. But we can't eliminate any of them right now, unfortunately. So we're going to have to work through the problem and eliminate them as we go. First things first, we got to assign a and b some values. This is going to be a, and that's going to be b. Next we have f of x equals cosine half x. So f of x obviously is going to be cosine half x. Now let's put all of those numbers into the formula. The lower limit, which is a, is going to be -4, and the upper limit, which is b, is going to be 0. Then f of x is cosine half x, so that comes next. And we need to divide that by the length of the interval, which is b minus a. So that would be 0 minus -4. Now there we have it. That's how it should look like after we plugged all the numbers into the formula and the function cosine half x. But we can simplify this a little bit further by writing it in this format. 1/4 integral of from -4 to 0 of cosine half x. All I did here was I just simplified this part, which 0 minus -4 is just 4, and I just moved the integral to the side. So next, we gotta anti-derive cosine half x. But be careful, cosine half x has a chain rule in it. So we need to account for that when anti-deriving it. But in the end, after you've anti-derived it, you should get something like this. 2 sine of half x. And then it's from -4 to 0. But before we go any further, it's always good to check your work. So let's just make sure 2 sine half x actually derives to cosine half x. Sine changes to cosine when you derive it. That's correct. And then the half x, it derives to 1/2. However, the 1/2 multiplies to the 2, and then 1/2 times 2 is simply 1. So it does get cosine half x. So that's correct. We can move on now. Now, we need to plug in 0 and -4 for x into 2 sine half x. Then, now let's just look at this and try to solve it. 0 times 1/2, that's just going to be 0. So sine of 0 is always 0. So first part's actually 0. So that's 1/4, 0 minus. Now let's put -4 into the equation. -4 times 1/2 is -2. So you gotta end there then. So 2 sine of -2. Then let's distribute the 1/4. 1/4 times 0 is just 0. So 1/4 times -2 sine of -2 is going to be -1/2 sine of -2. So we finally come to a relatively simplified answer. Unfortunately, however, that answer doesn't match with any of the answer choices. Because as you can see, all the numbers in the parentheses are positive. They're positive 2's. But we got something with a -2 in the parentheses. So did we do something wrong? Actually, we didn't do anything wrong. It's just because of the properties of the sine function. Let's step back a minute and think about the sine function. The sine is an odd function. So in essence, that means that, let's say, f of -a, that's just going to equal -f of a. And this is true of any odd function, including x cubed. So we have sine of -2. So what this means is sine of -2, that's just going to be negative sine of 2. So we can use this property to simplify this and get to an answer. So let's bring out the negative. If we bring out the negative, that's going to make that positive. So 1/2 sine of 2 should be the final answer. And that's going to be answer choice E. Boom, problem done. Next, I'm going to go over some common errors that many students make when trying to solve for the average value of a function. Solving these problems is relatively simple once you know how to use the formula for the average value of the function. However, there's always errors that could be made during the process. One of the biggest ones is not even using the correct formula at all. Some students use an entirely different formula to solve these kinds of questions. Try to avoid this error as much as possible. Another error that many students make is flipping the intervals. Let's say they assign from -4 to B and 0 to A. That's also wrong. Then there's also the problem of anti-deriving. This happens to a lot of students, including me. When you try to anti-derive cosine half x, some students get the answer of sine of half x, forgetting that you have to account for the chain rule. So yeah, try to avoid these errors as much as possible. Now there are many more errors you can make, and I'm not saying that these are the only errors that are possible when doing these questions, but these are the big ones you should watch for when doing them.
To end the video, we're going to display some problems so you can get some practice. When the problems pop up, pause the video and solve it. When you're done, unpause the video and we'll display the answers.